In this lesson, we're going to calculate the slope of a line. Now, slope is just a number that describes how steep a line is. And here I've drawn a line, and you can see that it's just as steep down here as it is here, as it is here. The steepness is the same everywhere on the line. So we can take these 2 points here, and if we can figure out how steep the line is between these 2 points, we'll know how steep the line is everywhere. We always think of slope as rise over run. The rise is the vertical change in the line between our 2 points, and the run is the horizontal change in the line between our 2 points. So if you'll look, you can see that the vertical change between this point and this one is 2 intervals or 2 steps. Okay, 1, 2. And the horizontal change between this point and this one is 3. 1, 2, 3. So rise over run is going to be 2/3. Now we don't normally write out the word slope. We normally write the letter M to stand for slope. And it comes from a French word that means slope, and that French word starts with M. So the M just carried over for us as well. Now, since slope equals rise over run, we can determine the sign of the slope by looking at the direction of the line. This line has a positive rise and a positive run. To get from one point to the next, it's a positive rise and a positive run. So uphill to the right, positive. Downhill to the right, we have if we're looking at this point and say this one, we have a negative rise compared to a positive run. So that's going to make a negative slope. A horizontal line has no rise at all. So if you're thinking about rise over run, the top number is 0 and the slope is 0. And a vertical line, the slope is undefined because the run is 0, so the bottom number is 0, that's undefined. So positive uphill to the right, negative downhill to the right. Horizontal line has slope of 0, that's the top number is 0. A vertical line has undefined slope, that's the bottom number is 0. So now we're going to determine slope by looking at a graph. And here's a line, and you can see these 2 points right here that I have marked in purple, and you can count the rise from one point to the other and then the run. So the rise, if we go left to right, the rise to get from the left point to the right point is actually -2. You have to go down. And the run would be +1 because, to go to the right would be a positive number. So -2, and on the bottom +1, and therefore the rise is, or the rise over run is -2 over 1. So the slope of this line is -2. And for this line, we have these 2 points right here. You can use any 2 points, but it's best if you use points that are at whole number, where your graph lines cross. So if I count the rise from the left point to the right point, it looks like 1, 2, 3. So the rise is going to be 3, and the run is going to be 1, 2, 3, 4. So the rise is 3, and the run is 4. So the slope of this line is +3/4. The rise is positive, and the run is positive. Now let's take a look at the slope formula. For any 2 points on a line, x1, y1, and x2, y2, they could be any 2 points on a line, and we'll just call one of them x1, y1, and the other one x2, y2. The slope is always like this. It's the difference between the y coordinates over the difference between the x coordinates. And this makes sense because we know that the top number is the rise. Well, the vertical change in the line is the rise. And we get that by subtracting the y coordinates, and then the bottom number is the difference between the horizontal coordinates, or the run. You definitely need to memorize this formula so you can use it later. And here I wrote this out so you could see that the difference between the y coordinates is going to give you rise. The difference between the x coordinates is going to give you run. Now find the slope of a line between 4,7 and 8,10. So this is a good example of what these slope problems look like. They just give you 2 points. And you could plot the points and just count rise over run like we did before, but you can also just use the formula. So the first point is x1, y1, and the second point can be x2, y2. And now let's plug our numbers into our formula. It's going to be 10 minus 7 on top and 8 minus 4 on the bottom. y2 minus y1 over x2 minus x1. And that's going to give us 3 over 4 as our slope. Now, if you reverse the points, if you call this one x2, y2, and this one x1, y1, you'll still get the same answer. Let's see how it works. This time we're going to have 7 minus 10, and on the bottom we're going to have 4 minus 8. That's going to be negative 3 over negative 4, but the negatives cancel out, and we still end up with positive 3/4. So it really doesn't matter because the slope is the slope no matter which 2 points you use or which one comes first. Now just to show you, here are the 2 points. This is 4,7 and this is 8,10. So you can see that to get from the left one to the right one, the rise is positive 3 and the run is positive 4. So the slope is 3/4. Now let's find the slope of a line drawn between the 2 given points, 4, negative 2 and negative 6, 5, and then we'll do part B in just a minute. So this is going to be x1, y1, and this point is going to give us x2, y2, and now we just plug in 5 minus negative 2, and on the bottom negative 6 minus 4. Okay, so the top, 5 minus negative 2 becomes 5 plus 2, which is 7. And on the bottom, negative 6 minus 4, which is negative 10. Now this is a negative slope, but we know that we can never leave a negative in the denominator, so you definitely should move it to the top. Now here I have plotted the point 4, negative 2, and now let's plot negative 6, 5, and here's the line, and you can see that it has a negative slope. So, it only takes a second to kind of draw a little sketch of your 2 points and make sure that the slope is positive or negative, whatever it's supposed to be. Now let's take these 2 points, so we'll call these x1, y1, and these x2, y2, and we'll put them in our formula, so it'll be negative 2 minus 5, and on the bottom, negative 1 minus negative 1. So the top number becomes negative 7, and on the bottom, negative 1 minus negative 1 becomes negative 1 plus 1, which is 0. So this is undefined because 0 is on the bottom. And if we draw the 2 points, we can definitely see that they're going to form a vertical line, and the slope should be undefined. So you really need to get clear in your head that when the line is vertical, the slope is undefined, and if you use the slope formula, you'll get 0 on the bottom. A lot of students know how to use the slope formula, but they don't get clear in their head whether undefined means 0 on the top or 0 on the bottom, and I hope you know that 0 on the bottom means undefined and 0 on the top of any fraction means 0. Now let's find the slope of a line drawn between these 2 given points, and we'll do 2 more parts here. Okay, so again, x1, y1, x2, y2. And we'll plug into our formula, so we'll get 4 minus 3 in the top, 2 minus negative 1 in the bottom. That's going to give us positive 1 over positive 3. And if we plot the 2 points, we can see that the slope is indeed supposed to be positive. Okay, last one, 6, 2 and negative 1, 2. And if we plug into the formula, we get 2 minus 2 in the top and negative 1 minus 6 in the denominator. And that gives us 0 over, it says 3, but that's not correct. There, fixed it. So I've got 0 on the top and negative 7 in the bottom. And of course that is 0 with 0 in the top. And if we look at the 2 points, we can see that they're going to form a horizontal line. And of course it has no rise at all. So the rise over run should be 0, which is what we got here.